Hi everybody. So in this video, we're going to look at plotting histograms as part of Year 1 A-level stats. And if you want to work along with me in this video, you can download a copy of a PDF from my website. I'll leave a link in the description below. So we're told that the variable x was measured to the nearest whole number, and 80 observations were taken and recorded in this table. We've been asked to draw a histogram, and then to find the probability of x being greater than 13. So we should know from our work at GCSE that when we have different class widths in our table, for instance, this has got a width of 2 and this one has got a width of 1, that our vertical scale becomes frequency density, not frequency. And we measure frequency as the area of a bar, not its height. So if frequency is the measure of the area of each bar, then this will be the product of the class widths on the horizontal scale and frequency density on the vertical scale. So frequency will equal the class width multiplied by the frequency density. But to work out the frequency density for each of these, this will be the frequency divided by the class width. But now we have a problem, because we need to plot this on a continuous scale, and this is given as distinct groups. For instance, where would we plot 10.5? Would it go in here or here? So to convert this to a continuous scale, we use something called continuity correction. And this is where we look at the upper and lower bounds of each of these measurements. So for instance, if we have a value of x being 7.5, well, to the nearest whole number that we're given, this would be rounded to 8. So any value of x that is greater than 7.5 or equal to, but less than the 10.5, because if it's greater than 10.5 or equal to that, it becomes 11 to the nearest whole number. Then this would be rounded to 10. So we'll have 10.5 here. So what this is telling you, if a value of x is greater than or equal to 7.5, but less than the 10.5, then we count it in this class. Because to the nearest whole number, it would round to between 8 and 10. So in our second class, we're looking at the values of x that are greater than or equal to 10.5. Notice here that it can't be equal to, but here it can, or less than the 12.5. Any value of x between this range would be rounded to either 11 or 12. And then in our next group, it'll be between 12.5, where it can be equal to that, but less than 14.5. And then finally, it'll be between 14.5 and 20.5. So you can see then that our class width, it isn't the 10 take away 8, it's 10.5 take away 7.5. So our frequency density would be the frequency of 12 divided by the class width of the difference between the upper and lower. So 12 divided by 3. And this will give us 4. And then we'll have 32 divided by the difference between 12.5 and 10.5. So 32 divided by 2. This will give us 16. Then we'll have 20 divided by 14.5 take away 12.5. This will give us 10. And then the 16 divided by the 20.5 take away the 14.5. So 16 divided by 6 will give us 8 over 3, or 2.6 recurring. Okay? So now we can plot each of these frequency densities against the class width. So between 7.5 and 10.5, we're going to go up to a frequency density of 4. And then between 10.5 and 12.5, we'll go up to 16. And then between 12.5 and 14.5, we'll go up to 10. And finally, between 14.5 and 20.5, we'll go up to 2.6 recurring. So that'll be about here. So this is our histogram. For part B, from the data, find the probability of x being greater than 13, which is the area that I've shaded in green. So the total number of observations greater than 13 will be the area of this bar, so 1.5 multiplied by 10. This will give us a frequency of 15, plus the area of this bar, which will be 6 multiplied by 2 2/3, which we know is 16. So the probability of x being greater than 13 will be the 31 over 80. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe, and you can download the full lesson and the PDF that accompanies this video from my website, mrmathematics.com. I'll leave a link in the description below.